To understand climate change, think of the game Tetris. For eons, Earth has played a version of this game with blocks of carbon. They enter the atmosphere as carbon dioxide gas from volcanoes, decaying plant matter, breathing creatures, and the surface of the sea. And they leave the atmosphere when they're used by plants during photosynthesis, absorbed back into the ocean, or stored in soil and sediment. This game of Tetris is called the carbon cycle, and it's the engine of life on Earth. What's the connection to climate? Well, when that carbon dioxide is in the air waiting to be reabsorbed, it traps a portion of the sun's heat which would otherwise escape to space. That's why carbon dioxide is called a greenhouse gas. It creates a blanket of warmth known as the greenhouse effect that keeps our Earth from freezing like Mars. The more carbon dioxide blocks hang out in the atmosphere waiting to be cleared, the warmer Earth becomes. Though the amount of carbon in the atmosphere has varied through ice ages and asteroid impacts, over the past 8,000 years, the stable climate we know took shape, allowing human civilization to thrive. But about 200 years ago, we began digging up that old carbon that had been stored in the soil. These fossil fuels, coal, oil, and natural gas, are made from the buried remains of plants and animals that died long before humans evolved. The energy stored inside them was able to power our factories, cars, and power plants. But burning these fuels also injected new carbon blocks into Earth's Tetris game. At the same time, we cleared forests for agriculture, reducing the Earth's ability to remove the blocks. And since 1750, the amount of carbon in the atmosphere has increased by 40% and shows no sign of slowing. Just like in Tetris, the more blocks pile up, the harder it becomes to restore stability. The extra carbon dioxide in the atmosphere accelerates the greenhouse effect by trapping more heat near the surface and causing polar ice caps to melt. And the more they melt, the less sunlight they're able to reflect, making the oceans warm even faster. Sea levels rise, coastal populations are threatened with flooding, natural ecosystems are disrupted, and the weather becomes more extreme over time. Climate change may affect different people and places in different ways, but ultimately it's a game that we're all stuck playing. And unlike in Tetris, we won't get a chance to start over and try again.
What is energy? Energy is defined by physicists as the capacity to do work. Energy is found on our planet in a variety of forms, some of which are immediately useful to do work, while others require a process of transformation. The sun is the primary energy source in our lives. Besides water, fossil fuels such as coal, petroleum products, water, nuclear power plants are sources of energy. For growing energy needs, energy has always been closely linked to man's economic growth and development. Recent strategies for development that have focused on rapid economic growth have used energy utilization as an index of economic development. This index, however, does not take into account the long-term ill effects on society of excessive energy utilization. For almost 200 years, coal was the primary energy source fueling the Industrial Revolution in the 19th century. At the close of the 20th century, oil accounted for 39% of the world's commercial energy consumption, followed by coal, which is 24%, and natural gas, which is also 24%, while nuclear would have 7% and hydro or renewable energy with only 6% accounted for the rest. Industrialization, urbanization, and unbelievable rise in the human settlements have multiplied the energy required by several times. Modern lifestyles and man's growing dependence on machines and equipment for his personal and professional work has added to the energy demand. Global oil demand continues to grow until 2040, mostly because of the lack of easy alternatives to oil in the road, freight, aviation, and petrochemicals, according to WAO 2016, published by International Energy Agency.
Renewable energy resources. Renewable energy systems use resources that are constantly replaced and are usually less polluting. Examples include hydropower, solar, wind, and geothermal energy from the heat inside the earth. We also get renewable energy from burning trees and even garbage as fuels and processing other plants into biofuels. For wind energy, it is the moving air or wind has huge amounts of kinetic energy and it can be transferred into electrical energy using wind turbines. For the solar energy is the light and heat procured from the sun. It is harnessed using an evolving technologies. Next is the biomass energy. When a log is burned, we are using biomass energy. As plants and trees depend on sunlight to grow, biomass energy is a form of stored solar energy. And for the hydropower, energy produced from water is called hydropower. Hydroelectric power stations, both big and small, are set up to produce electricity in many parts of the world. For tidal and wave power, the Earth's surface is 70% water. By warming the water, the sun creates ocean currents and the wind that produce waves. It is estimated that solar energy absorbed by the tropical oceans in a week could equal the entire oil reserves of the world, 1 trillion barrels of oil. For the geothermal energy, it is the energy stored within the earth. Geo for earth and the word thermal for heat. Geothermal energy starts with the hot molten rock called magma deep inside the earth, which surfaces at the same parts of the earth's crust.
Energy used impact the environment. All forms of electricity generation have an environmental impact on our air, water, and land, but it varies. Of the total energy consumed in the world, about 40% is used to generate electricity, making electricity use an important part of each person's environmental footprint. Producing and using electricity more efficiently reduce both the amount of fuel needed to generate electricity and the amount of greenhouse gases and other air pollution emitted as a result. Electricity from renewable resources such as solar, geothermal, and wind generally does not contribute to climate change or local air pollution since no fuels are combusted.
What is matter? In an ecosystem, matter refers to all of the living and non-living things in that environment. Living things means plants, animals, and organisms, while non-living things could be air, nutrients, and water. All plants and animals need both living and non-living things to survive. For example, human needs food, which is living, and water, which is non-living, in order to survive.
Flows of matter and energy in ecosystem. Plants captures the sun energy and use it to synthesize complex energy-rich molecules or the sugar from molecules of carbon dioxide and water. Because plants and other photosynthetic organisms use energy from the sun and inorganic molecules from the environment to produce organic molecules needed for life. They are called producers. The organisms that consume the producers are called consumers. derive energy and materials from breaking down. When producers, molecules use them to synthesize their own structures, and then they may be consumed by other organisms. Decomposers, or the organisms that break down dead producers and consumers and organic waste, obtain the energy they need to live from chemical bonds of the dead and waste matter. The energy is transferred both to the decomposer for growth and development and to the ecosystem as heat energy. Food webs and energy pyramids are models or the representation that can be used to track the flow of energy in the ecosystem. Food webs detail the flow of energy through the populations and ecosystems, whereas the pyramid model quantifies the flow of energy through various levels in an ecosystem. Unlike matter, as energy flows through an ecosystem in one direction, from photosynthetic organisms to herbivores to omnivores and carnivores and decomposers, less and less energy becomes available to support life. This loss of usable energy occurs because each energy transfer results in a dissipation of some energy into the environment as heat. Continual input of energy from sunlight is necessary to keep ecosystems organized and functioning. For the cycle of matter and energy, matter energy includes many different kinds of substances, many of which occur in cycles throughout the biosphere. These substances include carbon, nitrogen, phosphorus, oxygen, and many other substances are used by organisms as they grow, reproduce, and die. This creates many natural cycles within the biosphere. We have a lot of evidence that describes the carbon flow throughout nature. We know that photosynthesis operates by taking carbon dioxide out of the air and using it to create sugars. The process of respiration, which happens in most eukaryotic organisms, releases carbon dioxide after the energy is harvested from the bands of sugar. However, we also know that humans are alternating this cycle with the burning of fossil fuels, adding massive amounts of carbon dioxide to the atmosphere that changes how heat is trapped as well as how plants all over the world grow.